Today we are going to go over the precedent rules of arithmetic, which allow us to work out calculations involving brackets, powers, division and multiplication, addition and subtraction, and let us all arrive at the same answer. Then afterwards we're going to go on and do calculations involving positive and negative numbers and use rules for addition, subtraction, multiplication and division. But first, let us look at this expression. It's 2 plus 4 times 3 minus 1. And let us work it out. Well, we can work it out first by moving from left to right. And if we do that, then we will add, then multiply, and then subtract. If we do that, we get 2 plus 4, which is 6, times by 3 is 18, minus 1 gives us the answer 17. But if we change the order, the calculation, and we use add first, then subtract, and then multiply, what answer do we get? Well, 2 plus 4 is 6. Do the subtract next. 3 minus 1, which is 2. So 6 times 2, the answer is 12. Or we could multiply first, then add, followed by subtract. Well, if we multiply first, that's 4 times 3, which is 12. Do the add, 2 plus 12, which is 14. Then subtract, the answer is 13. And so on. And as you can see, we get different answers according to the order in which we do the operations. So that's not very good. So we need to have a precedence in which we know the order in which we do the calculation. And the order that most people use is we do brackets first, followed by powers, and then multiplication and division, and then finally addition and subtraction. Now that's a lot to remember. So there's an acronym to allow you to remember it. And that acronym is BODMAS. B-O-D-M-A-S. B for brackets, O for powers, D for division, and multiplication for the M. And these two go together because they have the same priority. A for addition, and S for subtraction. And these two go together because they have the same priority. So if you remember BODMAS, B for brackets, then O for powers, followed by division and multiplication, and then finally addition and subtraction. If you want to calculate any expression, you use that order and you won't go wrong. So, why don't we look at some examples? Take, for example, the first one that we started off with. 2 plus 4 times by 3 minus 1. Now, using BODMAS, we should have no problem working out this expression. We do the times first, so it's 2, add 12, minus 1. Now, the addition and subtraction have the same order of priority, so we work from left to right. That's 2 plus 12, which is 14, minus 1, which is 13. Look at this next example. Here we've got brackets, and using BODMAS, brackets are done first. So 3 plus 5 is 8. So our expression becomes 2 times 8, which is 16. Couldn't be easier. What about the next one? 9 minus 6, but I forgot to add the plus 1. Now in this case, we've got the subtract and the add together. So we've got the same priority. The rule is work from left to right. So we say 9 minus 6, which is 3, add 1, which is 4. The last two involving powers. 3 plus 2 squared. Well, using BODMAS again, we do the squares, the powers first. 2 squared is 4, so our expression becomes 3 plus 4, And 3 plus 4 is 7. And finally, this expression, 3 plus 2 all squared. Now we've got powers and brackets. But remember, using board maths, we do what's inside the brackets first. So it's 3 plus 2, which is 5. And then we have to square the 5, which is 25. Now in these two last examples, we've got the same numbers, and we've got a square, but you've got two totally different answers. And the reason why is in this one, the square is for the things inside the bracket, the 3 plus 2. Whereas in this one, the square relates to just the 2. So remember, when you're doing any calculations which involve operations such as brackets, powers, division, multiplication, subtraction and addition, use board maths and you won't go wrong. Board maths means brackets first, then powers, followed by multiplication and division, and then addition and subtraction. And when you have operations of the same priority, you just work from left to right. Nothing could be easier. And now I will move on to calculations involving positive and negative numbers. Now, what are positive and negative numbers? Well, if we take all the real numbers except 0, all real numbers can be either positive or negative, and of course except 0. Now, where are those numbers? Well, if we look on a number line and position 0, all the positive numbers are to the right, and all the negative numbers are to the left. And we represent the numbers on the number line like this: positive 1, positive 2, positive 3, positive 4, positive 5, and so on. Negative 1, negative 2, negative 3, negative 4, negative 5. Notice how we've written the numbers, the positive numbers and the negative numbers. We write positive 3 like this and negative 4 like this. The sign of the number is written as a superscript. Now we do this to help our understanding so that we don't confuse the sign of the number with addition and subtraction. But of course, with practice, we drop this and we just use the normal standard notation. But for this session, I'm going to use the superscripts just to help our understanding. But what about calculations involving positive and negative numbers? What about addition and subtraction and multiplication and division? Well, we'll take some examples. If I take these two examples, negative 4 add positive 5 and positive 4 subtract positive 9. If I have those two calculations, what do they work out to be? Well, in the first instance, we can use a number line to help us evaluate them. And we have to remember that using a number line, addition means you count on in that direction, and subtraction means you count back in that direction. So using those two little rules, we'll calculate this expression and then this. So take this one to begin with. Negative 4 add positive 5. Start at negative 4 on the number line and count on 5. 1, 2, 3, 4, 5. So negative 4 add positive 5 gives me the answer positive 1. For the other example, we've got a subtraction. So we start at positive 4 and we subtract positive 9. So start at positive 4 and count back 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So positive 4 subtract positive 9 gives you negative 5. what could be simpler. Now, to simplify matters a little bit further, it really is a faff to keep writing all these signs. And because positive numbers are the numbers that we usually use in calculations, we drop them. We drop the sign. So positive 5 can be written as just 5, and we know that. Positive 1 is equal to 1, and positive 9 has 9. And it's understood by everyone that where you have numbers with no sign written there, then they are positive numbers. And I'm going to use that in all my calculations following on. But if you notice, in this calculation and in this one, we've added and subtracted positive numbers. But how do we add and subtract negative numbers? Well, to try and generate an easy rule, I'm going to look at some patterns of both addition and subtraction. And we'll start with addition. And we'll start with something that we know. If we start with 5 plus 2, we know that is 7. And then I'm going to write a sequence of calculations which follow on from this. 5 add 1 is equal to 6. 5 add 0 is equal to 5. Notice in this sequence of addition, the answers decrease by 1 as the numbers that we add decrease by 1. So, if we follow the pattern and we take 5 add negative 1, because negative 1 is 0 subtract 1, is 1 less than 0, then it must equal 4 if we continue the pattern on. And 5 add negative 2 must equal 3. And 5 add negative 3 must equal 2. And 5 add negative 4 must equal 1. Now, if we look at these additions of negative numbers, we can actually write these calculations as subtractions of positive numbers. So 5 add negative 1 would be the same as 5 subtract 1, and you get the same answer, 4. Similarly, 5 add negative 2 can be written as 5 subtract 2, and you get the answer 3. 5 add negative 3 can be written as 5 subtract 3, gives me the answer 2. And then 5 add negative 4 is the same as 5 subtract 4, which is 1. So, when we have the addition of negative numbers, that's the same as the subtraction of the positive number. So if I had these two examples, 8 add negative 10 and negative 9 add negative 5, using that rule, how would we calculate the answer? Well, we take 8 add negative 10, that's the same as 8 subtract 10. And thinking about the number line, you start at 8 and you go back 10. So you go back to 0 and then another 2. You get to the answer negative 2. And with this example, negative 9 add negative 5, we can rewrite that as negative 9 subtract 5. Again, visualising it on the number line. Start at negative 9 and you go back 5. Go back 5, so you land at negative 14. So when we have the addition of negative numbers, it's always easier to change them into subtraction of positive numbers. But the one thing that we haven't done is the subtraction of negative numbers. So again, I'd like to use a pattern to help us work out the rule that we're going to use. If we start off with what we know, 4 subtract 2 is 2. So 4 subtract 1 is 3. And 4 subtract 0 is 4. Notice in this sequence of subtractions, the answers are going up by 1 as the numbers that we are subtracting decrease by 1. So if we continue the pattern in the calculations, the next calculation would be 4 subtract negative 1. And the answer will be 5. You add 1 onto the 4 to make 5. And 4 subtract negative 2 will be 6. And 4 subtract negative 3 will be 7. And 4 subtract negative 4 is 8. Now again, if we look at these subtractions of negative numbers, what calculation would be easier to do using the numbers but still arriving at the same answer? Well, I think it's quite obvious. For this one, it's 4 add 1, and that gives us the answer 5. The numbers are the same, but the operation and the sign are different. For this one, it'd be 4 add 2, and that will give us 6. For this one, it'd be 4 add 3, and that will give us 7. And finally, 4 add 4, which will give us 8. So, if we look at our pattern, we can see that when you've got the subtraction of a negative number, that's the same as the addition of a positive number. So we'll use that rule to work out these calculations. If we take 8 subtract negative 10 and negative 6 subtract negative 13, what answers do we get if we use our rule? Well, we change the subtraction to the addition of a positive number. So it's 8 plus 10. And what could be easier? That's 18. For this one, you've got negative 6 add 13. Slightly harder, but not too difficult. Think of negative 6 on the number line and go forward, count on 13. You count on 6 and then another 7. So the answer is positive 7, written like that. So how can we combine all these rules together in a nice, easy way for you to remember? Well, this is one way. If the operation and the sign are the same, like this, then the calculation works like an addition of a positive number. If the operation and the sign are different, like this, then the operation works like the subtraction of a positive number. Now, if you remember those 2 golden rules, then the addition and subtraction of positive and negative numbers is dead easy. Now, we've talked about addition and subtraction of positive and negative numbers, but what about multiplication and division? Well, we'll start with what we know. We know how to multiply and divide positive numbers. We know that 5 times by 5 is 25, and 5 divided by 5 is 1. Dead easy. But what about the multiplication and division of negative numbers? Well, I'll use patterns the way I did before in addition subtraction. And I'll start off with this calculation and continue doing a sequence of multiplications that involve negative numbers. And we'll see if we can get a rule coming out from the pattern in the calculations. For the next calculation here, I'll say this is 5 times by 4. And we know that is 20. 5 times by 3 is 15. 5 times 2 is 10. 5 times 1 is 5. And 5 times 0 is 0. Now notice, in these multiplications, the answers are going down by 5 as the number that we times by decreases by 1. So the next calculation in the sequence would be 5 times by -1. And if we use the pattern that I've just stated, we subtract 5 from 0. And if we subtract 5 from 0, we get -5. The next calculation would be 5 times by -2. -5 subtract 5 is -10. 5 times by -3, -10 subtract 5, -15. And we'll do just one more, just to see if we can spot the pattern, and the pattern is working. 5 times -4, take -15 and subtract 5, that's -20. So look at our multiplications by a negative number. We get a negative number answer. So when we multiply a negative by a positive, we'll always get a negative answer. And vice versa. If we multiply a negative by a positive, we'll get a negative. So, if I give you these two examples, 6 times by -5, it's dead easy to work out the answer. You just multiply the 6 by the 5 to get 30. The signs are different. Remember, this is +6 times by -5. The two signs are different, so the answer is a negative number, -30. If we take -4 times by 3, multiply as normal, 3 4s are 12, and then take into account the signs. This is a negative, this is a positive, two signs different, so the answer is negative. And the same goes for division. And we can just double check that by looking at these two calculations. -30 divided by +6 must equal -5. And -12 divided by +3 must equal -4. So, when the signs are different, when you multiply positive and negative numbers together in pairs, the answer will always be a negative number. But we haven't finished just yet. What if you multiply and divide by negative numbers? What happens then? Well, again, I'm going to use patterns. I like using patterns because it gives me a bit of confidence that I'm doing things correctly. And I always start off with things that I know. So if I start off with -5 times by +4, I know the answer is -20 because the signs are different and 5 times 4 is 20. Next one in the sequence, -5 times by 3. That will give us -15. -5 times 2, -10. -5 times 1 is -5. -5 times 0 is equal to 0. Now look at the pattern. It's a bit like a déjà vu. We've done this before. Look at the answers. You can see that we are increasing by 5 each time as we multiply by 1 less each time. That seems a bit odd, but stay with me. The next multiplication, if we keep the pattern in the calculations the same, would be -5 times by -1. And according to our pattern, that will equal 5 more than 0, which is positive 5. Negative 5 times negative 2, which is the next calculation in the sequence. That would be 5 more than 5, which is 10. Negative 5 times by negative 3 is 15. Negative 5 times negative 4 is 20. So it's really great to see that when we multiply negative numbers together in pairs, we get a positive answer. Negative by negative gives it a positive. Negative, negative, positive, negative, negative, positive, negative, negative, positive. Isn't that great? Dead easy. So, if I had this calculation, negative 6 times by negative 3, you multiply as normal. 6 times 3 is 18. And the answer is positive, positive 18, because it's 2 negatives makes a positive. And the same goes with this one. If we had negative 9 times by negative 2, 2 9s are 18, 2 negatives, the answer is a positive. So again, we get the same answer, 18, but different numbers in the calculation. But remember, where else did we get a positive answer? When you multiplied two positive numbers together. So if you multiplied 6 by 3, you'll get 18. And when you multiplied 9 by 2, you get 18. So when the signs are the same, then the answer will be positive, whether they are two negatives being multiplied together or two positive numbers being multiplied together. Now that's a lot to take in for multiplication and division of negative numbers. I'd like to summarise that bit by, again, using a diagram. When the signs are the same, a positive times by a positive, or a negative times by a negative, the answer is positive. And it's a positive number. When the signs are different, a positive times by a negative, or a negative times by a positive, the answer is negative. And the same rules go if you divide. So, if I had these examples, negative 6 divided by negative 2, my answer will be, do the division first, 6 divided by 2, which is 3, and then think about the signs. Negative, negative, signs the same, so the answer is positive. And if we had this division, negative 12 divided by positive 3, do the division as normal. 12 divided by 3 is 4. Think of the signs. Signs different, negative and a positive, so the answer is negative.